All right, so we're in a unit on systems. You guys have been around systems since algebra. Um, I'm aware of that. We tried to show you a new idea that uses matrices. That matrix method, it's kind of fair game for any problem that you need to solve a system. Obviously, this mini check was a good place to do it. But now we're going to get into some kind of like standard application problems. I'm sure that the feel of these problems will sound similar. Some of them you probably have worked out, something like it already. I see you guys some of you are working on some of the other problems, but I wanted to kind of just walk you through ABC, kind of get you back into the swing of things. And some of these also intentionally are a little different, a little more of a trigonometry class level question, not just your basic problem from maybe algebra. But still, everything goes back to a system. And once you get these things set up, you can solve the system any way that you want. Just by the way, this paper is kind of doubling as a couple examples, and then it'll be like an assignment. Remember, an assignment's a little different than a homework. It's something that's graded for correctness, and usually I give you a couple days to think about it, which is the case here. In fact, tomorrow I'll give you some time in class to literally work on this assignment so you can kind of plan accordingly. Some people finish it tomorrow, and then you can turn it in tomorrow. Some of you'll want that extra day, and that's fine. That's why it's not due until Friday. So did you look at this first one? I wrote down some stuff, but did you read it? We basically have a trip going one way and the other way. You kind of get the feeling that there's like two equations. Yeah, that's pretty common. There's going to at least be two equations since we're creating systems. Now, you want to understand that R1, as it says in the last sentence, is the airspeed of the plane. I'm not a pilot. We don't have anyone in my family that is, but the airspeed of the plane would be like the throttle, and as you basically throttle up the jets. Okay, just because you throttle up the jets, though, just because you push on the gas pedal, doesn't mean that you always go the same speed. It depends on, in a car, if you're going uphill or downhill. In an airplane, it depends on if the wind's blowing with you or against you. So R1 minus R2 would be like the overall speed. I added this word overall. I kind of like that. If you want to add that above it, maybe. Because you got to understand that we've got the throttle of the jets, but the wind is pushing against. Kind of like you're going uphill. And then the overall speed when you're with the wind is adding those two together. But you got to understand that R1 and R2 are these two separate speeds. Okay, but if I add them together, it's kind of like I have one speed. I have one overall speed, which gets us to the equations. Now, a lot of kids like, so what equation do I write? When I see a problem like this, I see distances, rates, and times. I'm sure you do too, but distances, rates, and times have always been connected by the infamous distance equals rate times time, kind of like your most basic science formula. So think about this with me. You can create two equations that involve distances, rates, and times. The one equation would be when we're flying out to California. So what's the distance out to California? Well, of course, it's 2,000. What's the rate out to California? Well, it's the overall rate against the wind. Just like Bob Seger sang, against the wind. Now the time is given to you. It is 4 hours and 24 minutes. There has to be something in you that kind of says, that's going to be strange to write down 4 hours, 24 minutes. We need to do a little bit of side thinking as far as converting 4 hours, 24 minutes into something that is just pure hours. So remember, there's 24 minutes would be a 24/60th of an hour. And basically, you can take that fraction and think of it as then just 4.4 hours. Again, 24/60th of an hour is 0.4 of an hour. So 4.4 will be a good number to put into for our time. Just curious, can you write the other equation? Are you thinking? There's another equation. It's the one when you're going back. It uses a distance, a rate, and a time. Okay, it's not the same equation, but it certainly has some similarities. It's the same distance. It's not the same rate, because this time you're going with the wind. So we want to add. And it's not the same time. It would be kind of weird if it was the same time. It's obviously less time. Okay, now that's not like your standard system, but it is a system. You have to look at that and say, yeah, 2 equations, 2 variables, we're in system land. And you just want to kind of make it look normal. So, do stuff that makes it look normal. Like, don't hesitate to distribute. And in a similar fashion, your bottom equation. Also, I'm going to just rearrange it a little bit because I'm used to seeing the 2000 on the other side. So I'm going to rearrange and put 2000 over here. But I basically just distributed 4.4. And obviously I can distribute 4. I even made a little mistake there. I forgot the R2 because these equations start to look so similar. Okay, but they are 2 different equations. And therefore they probably have an intersection point. That intersection point is going to be R1 and R2. Just curious, when you see this, what solving strategy kind of, jumps out at you? Are you still kind of like in matrix land? You just took a little mini check, hopefully did pretty good. Yeah, you can think of this as a matrix A and a matrix B. Not every problem maybe is screaming matrix, but I'm not sure why this one can't be. If you're so desire, you could pop that into your computer if it's still handy. I actually want to show you. I know a lot of you don't use a graphing calculator, but some of you might, and I know a few of you do, that the graphing calculator actually has a matrix button, and basically it's a matrix menu that does the same thing that you were doing on your computer. Hey, be careful. Sort of the one thing on this problem, be careful whether you're using a computer or a calculator or just watching negative 4.4. It's kind of like the one thing in this problem people miss. You're going to wonder why your answer doesn't make sense. Negative 4.4. Okay, but I know this looks a little different, and most of you are not doing it this way, but I'm basically typing in matrix A and matrix B, and I will do the same thing, which is A inverse times B. It's just done on the screen. Okay, R1 and R2. R1 and R2. Now, you kind of have to think about, okay, what's really being said here? Well, it's being said that the speed of R1 is 477 miles an hour. I think the decimal should be considered here. So we've got a little extra, but it's 477 miles an hour, 0.27. And then 22, 72, or maybe 73. I don't think we have to change it into a fraction. You're used to seeing speeds written as decimals. What I do want you to do, though, because this is like a little application paper, is I want you to, at a minimum, I want you to label your answers. What do I mean by that? Well, I want you to show me that you understand that 477 is the speed of the plane. It's the speed of the plane. I'm not going to make you write a sentence, but if when you get graded, if you can put a couple words after it. And similar here, airspeed, or excuse me, wind speed. So again, label your answers. Don't just say X equals or Y equals. And I'm not going to make you write a sentence, but if you can at least label it. Just kind of one extra thing with this problem. Okay, I know most of you, you're happy, you got the answer, let's move on. But what really are these two numbers? What do they really mean? Well, they mean what you said. They mean that if you add your speeds, then the plane is actually, if you look up in the air at the plane, it's traveling 500 miles an hour. And if it's traveling 500 miles an hour for 4.4 hours, oops, I did that one backwards. If it's traveling 500 miles an hour for 4 hours, then you went 2,000 miles. And just kind of the opposite, if it's traveling against the wind, I guess that was actually the first one, but if it's traveling against the wind, then the overall speed of the plane is 454 miles an hour. And that also comes out to 2,000. So you can kind of check your work after you use your system to get those two answers. Letter B. Let's take a look at letter B. Remember, these three problems are intentionally a little bit kind of unique. They're kind of special. If you've not read letter B yet, you can see here when you do read it that we've got some stuff with mixtures, and it really looks more like a chemistry problem. It's sort of your classic mixture problem from chemistry. Don't forget good math to identify your unknowns. In this problem, the unknowns were R1, R2, and they were sort of already identified in the sentence. But in this problem, your unknowns, it might be helpful if we start there. So again, good math is to say, what is X, what is Y? Okay, now a lot of people realize that X has something to do with 5%, but what we want to be careful about is that we don't say that X equals 5%. That actually doesn't make sense, because what we're really trying to find is the amount of 5%, the amount of weak. And in similar fashion, Y is the amount of strong. Now, when I say amount, I literally mean a certain amount of liters. Am I going to dump in, 2 liters of this one and dump in 1 liter of this one? Am I going to dump in an equal amount of liters? So when I say amount, we literally mean how much liquid you're going to pour in. I like this problem because the first 3 words, maybe we'll say the first 4 words, but it says Bob needs 3. Bob needs 3 is an equation, and it's one of those simple equations sometimes we overlook, but it's the classic total equation. How do you say Bob needs 3? With the classic X plus Y equals 3. There's going to be some amount of X, there's going to be some amount of Y, and when he's done dumping them together, he needs 3. Okay. Again, it's a very simple equation. Maybe it's 2 plus 1. Maybe it's 1.5 plus 1.5. Or maybe it's some random decimal that we need to do some thinking about, which is why we have a second equation. The second equation has to do with the percentages. Now, what you have to understand is that every time you dump in an X, 5% of X, mathematically 0.05 times X. But what that really means is 5% of X is going to be pure chlorine. Okay, now the rest of it's water. In a similar fashion, 9% of Y. When I dump that in, 9% of it is pure chlorine. Okay, now yes, we're going to use 8% over here. But I also want you to realize that just like we talked about the percents in the given, it actually doesn't make sense just to stop here and say equals 8. You have to understand that a percent is always of something. So it's 8% of the total. Okay, 8% of 3. And what this is also saying will be pure chlorine. Again, I got 3 liters. Okay, I got 3 liters. Only 8% of those liters is pure chlorine. In other words, if you do that arithmetic, it's barely a quarter of a liter. Okay, here's our 2 equations. Now I'm going to erase the 083. I just want to make sure that you're not confused that there's 2 numbers over here. Honestly, what it really is just ultimately the 0.24, but that you understand that that came from multiplying those together. Okay, well, it's a system chapter, so you got to solve it. As we've said a couple times, matrices are fine. I kind of want to make sure you don't forget. And this problem is really, even though it has decimals and you might want to use matrices, it's not really against the rules or against the law to multiply by a decimal. In fact, it's actually not too bad. Negative 0.5 times x is negative 0.5x times y. So it's a quick way. It's a quick way to get some opposites, just so you remember. And 3 times 0.5, remember when you were talking about decimals in junior high, that would be the same as 15, but you just move the decimal 2 places, which is really 0.15. So if you want to give yourself a little exercise, your brain a little exercise. And then when I add these equations together, of course, 0.9 and negative 0.5 is 0.4. 24 minus 15, of course, as a decimal is 0.9. And then all I got to do is divide. I would obviously use your calculator, but 0.4 into 0.9, I did it ahead of time. It comes out to 225. Now, 225 is the amount of liters. It's 225 liters of, sorry, that should actually be like a capital L. It's 225 liters of the strung. Which makes a pretty easy way to figure out what's left over. We know that what's left over has to equal 3. That's why we're only going to need 0.75 of the week. Even if you're not a chemistry buff, think about what's really happening here. We're basically diluting the strong solution. So we're taking most of the strong and we're diluting it with a little bit of weak. And when it's all over, we end up with 8% mixture. Okay. Listen, what I did here is a good example of what I expect you to do on the assignment. Set it up. Obviously, write your equations, solve them, and then label your answer. Now, I solved this one without matrices. I'm sure there's going to be a couple problems that you're going to feel like that's actually a little easier. I'm not requiring you to solve in a certain way. But I do encourage you to kind of mix it up. And letter C is one last problem here that we can kind of mix up a little bit with how we solve it. Make sure you read it. We've got the perimeter of a triangle. I'm going to encourage you guys to do a little thinking on this because there's some common mistakes, but let's start at the same place. I'm kind of thinking X, Y, Z. If you were thinking A, B, C, hey, that's fine. But to put us all on the same page, let's let X be the shortest side. Let's let Z be the longest. And then obviously Y is the one in the middle. Remember, these are all the sides. Maybe we should say that. Careful, it's a little too easy just to kind of watch the teacher the whole period. Can you write any of those 3 equations? I encourage you to try it because this is what you're going to have to do for a grade. Can you write any of those three equations? Now, it matters which variable, gets the number 3 when you say that the longest side is 3 times the shortest. So which variable are you putting a 3, or are you multiplying by 3? And then when you write the last sentence about a side being 17 inches more, it matters where you put the plus 17. You have to be careful about this stuff. Some people, I know you don't really like this kind of problem. Some you like thinking this way, but it matters. And a lot of it boils down to which side is the shortest and which side is the longest. So it looks good on that first equation. I expect that you guys would write that. That's a simple perimeter. How do we describe the longest side is 3 times the shortest side? How do we say the longest side is 3 times the shortest side? You feel like you have it the right way? You actually can think of it as the longest side is, in other words, z equals 3 times the shortest side. It really actually writes the way it reads, but you should think to yourself, okay, yes, I'm tripling a short distance to equal long distance. You also could use 1/3. Once in a while, somebody puts 1/3 on z. That's obviously the same thing. How about the last one? Again, it says that the longest side is 17 inches more. If the longest side is 17 inches more, then I need to add 17. I need to add 17 to the other sides. So it turns out that I want my plus 17 to kind of counteract that. And then we have this little mishmash of being 1/2 the sum of the other sides. If 17 is 17 inches more, then I actually need to up 17 to the other sides, okay, to get it up to that value. How about rearranging these equations? Okay, especially if you're thinking matrix method, then you're going to want to be thinking about making the equations be in the right organization. If you subtract 3x, then I can make that equation equal 0. By the way, I could have subtracted z. And had the same conclusion, but you got to choose one method. And then over here, we have to recognize that not only is 1/2 a coefficient, but they need to both scoot over here so that 17 can be by itself. So I'm going to distribute 1/2, but I'm going to scoot it over, which is actually going to give me -1/2 x, obviously -1/2 y, and then that z is still over there. Okay, so don't be scared to kind of rearrange your equations, but please let 17 sort of stand alone. Let it be by itself on that side. This equation doesn't really need changed, but so that I can think matrices, we can kind of put all those together. And here's your other matrix, a little bit sideways, but you got matrix A and matrix B. Okay, so system application, trying to set up the problems, most people realize is the harder thing to do. Solving them is usually pretty easy, but we do want to get them set up correctly so that when you solve them, you end up. Now, I'll give you this option if it seems like it's good enough. If you get your 3 answers and you already kind of said how they are labeled, then I don't think we need to rewrite it again. So for me to put 13 beside that and 31 and 39, first of all, they make sense because you got the shortest, the middle, the longest. If you check them, they do add to 83. And if you check X and Z, you can see that this one is 3 times this one. So you can kind of check your answers and see that they actually fit your equations. Okay, so you sort of decide. I'm going to give you time to work on this tomorrow. That means you could just come ready to do that. Maybe you want to do some of them ahead of time. And that way, if you have a question, you can ask it tomorrow.